Good morning to everyone. Myself, Dr. M. Kandasamy, Assistant Professor, Department of Chemistry, K. Ramakrishnan College of Technology, Trichy. I am going to deliver my research topic, photovoltaic performance of dye-sensitive solar cell using amine functionalized TiO2 nanofelt as a photonode material prepared using a simple solution route. Introduction: why need solar energy? Thermal power is one of the most dominant energy sources in the rest of the world for energy production. Particularly in India, more than 60% of electricity production comes from thermal power plant and 3% of power production comes from nuclear power station. First of all, this is not environment friendly because during the electricity production, I mean thermal power production, in enormous amount of toxic gases produced like greenhouse gases, nitrous oxide, carbon monoxide, carbon dioxide. According to EIA reports, Environmental Impact Agency reports, every power plant produced lakhs tons of greenhouse gases. And another side, we can see these slides. One of the most famous newspaper in India, the name is Indian Express, has published the article on last October 2021 recording shortage of coal. So considering this fact, urgently we need alternative energy sources. As accordingly, we are trying to utilize the renewable energy sources nowadays. Solar energy is the one of the most alternative renewable energy source to thermal power plant because Earth receives enormous amount of sunlight, environment friendly, so there is no greenhouse gases emission, no need fuels, no need water, and light-term stability. In recently, almost 80% of commercial market utilizing the PN junction solar cell. The highest power conversion efficiency of 29.4%. This is the lowest percentage. Even though there is no alternative to silicon solar cell, but while using the silicon based solar panels, the cost wise is very high expensive, so we need an alternative to silicon based solar cell. In for alternative, Dyson solar cell is a very low cost compared to silicon based solar cell, lightweight, flexible, easy fabrication, high performance under real indoor and outdoor condition. Recently, DSCC achieved approximately 14% of power conversion efficiency. So based on the, I designed my work in the DSCC. In the experimental part, I have used TiO2 nano belt, amine functionalized TiO2 nano belt using the simple solution route, 1.5 ml of optimum volume of APTS as a amine source. By the simple solution route, we produced amine functionalized TiO2 nano belt. So solar cell device fabrication, photonode prepared using Dr. Prepared techniques, N719 dye used as a dye sensitizer, platinum counter electrode prepared using thermal decomposing method, and imidazole based liquid electrolyte used in this device making, FTO substrate used as a conducting substrate. So result in discussion, SEM and TEM images reveals the TO to nanobelt morphology. In XRD patterns, the diffraction pattern of all TO to 2 theta values showed annotates and rutile faces TO2 and well matched to the reference given reference JCPDS card number. We can see that the diffuse reflection spectra of the absorbed photon or thin films, and figure B, UV visible absorption spectra of dye disabsorption studies. We could see that in figure B, dye disabsorption studies compared to bare TO2 nanobelt, amine functionalized TO2 nanobelt possess higher dye loading on the TO2 surface. Due to the higher surface area and porous for facilitating the dye molecules absorption. So, in application photovoltaic performance of DSSC using TO2 nanobelt and amine functionalized TO2 nanobelt based photonodes, and the short circuit current density, open circuit voltage, and the fill factor, all the photovoltaic parameters are given this table. We can see that pure TO2 compared to pure TO2 nanobelt, amine functionalized TO2 nanobelt photonode device giving highest short circuit current density and cell efficiency. So, this improvement of cell efficiency can be attributed to higher dye loading due to APTS amine on the surface of TO2 bonded with carboxylic group of N719 dye, which facilitate the higher dye loading, where amine act as electron transporter between TO2 and dye molecules. Thus, TO2 APTS modified TO2 photonode provide more number of photogenerated electron to FTO substrate. Thus, increases the short circuit current density and cell efficiency. Conclusion: APTS modified TO2 nanobelt synthesis by using ultrasonic assisted technique. Prepared material was characterized by suitable techniques. The photovoltaic performance of APTS TO2 nanobelt photon based DSSC delivered higher overall conversion efficiency of 6% compared to unmodified TO2 nanobelt. The better photovoltaic performance associated with APTS TO2 nanobelt photon DSSC owing to APTS can also improve the dye absorption and light harvesting at the photonode, which effectively promote the electron transfer. Thus, reduces the hole transport electron hole recombination rate. Thank you. Thank you so much for your listening.